இது வரைக்கும் எங்கள் சேனலை சப்ஸ்கிரைப் பண்ணாட்டினா ஃபஸ்ட்டு எங்கள் சேனலை வந்து சப்ஸ்கிரைப் பண்ணுங்கள், மறக்காமல் பெல் சிம்பலை வந்து கிளிக் பண்ணுங்கள். அப்போ தான் எங்கள் வீடியோ எல்லாமே உங்களுக்கு விரைவாக வந்து சேரும்.
18 group of elements is also called B block elements, because why we are calling a B block elements means the entering the last electrons enter into B orbital, then only we are calling a B block elements. Okay, the last upcoming electrons enter into B orbitals, so that type of elements is also called B block elements. Here group 13 contains in generals B block elements have as a highest acceleration state, it's nothing but +8 xenon. B block elements only have a highest acceleration state +8. The element name is xenon. Group 13 element is called boron family. Boron family contains this type of elements: boron, aluminium, gallium, indium, thallium. Boron, here boron and aluminium has a highest acceleration state +3, but gallium, indium, thallium has a lowest acceleration state +1. Why boron and aluminium has a highest acceleration state but gallium, indium, thallium is the lowest acceleration state? Because of inert pair effect. Inert pair effect, this variability of acceleration state should be occurs. What is mean by inert pair effect? That is, consider boron, the atomic number of boron is 5, electronic configurations 1s2, 2s2, 2p1. Here this p electron does not involved in bonding, but this s electron involved in bonding. That process is called inert pair effect. I have to repeat, that is, outermost p electron does not involve the bonding, chemical bonding, but this s electron involved in chemical bonding. So that process is called an inert pair effect. This variable balances, this variable acceleration states are coming because of inert pair effect. Now boron, these two are acidic in nature, remaining three are basic in nature. Basicity in commonly the non-metal oxides, group 13 to 18 are non-metals. Non-metals forms a basic oxides with oxygens. Now boron forms in a boric oxide. It is in a more acidic, at the same time melting point as well as the boiling point is very high. So this boron is act as a semiconductor also. This boron's maximum behaves as a Lewis acid. What is meant by Lewis acid? That is, Lewis acid is nothing but accept lone pair of electrons. The compound which accept a lone pair of electrons is called a Lewis acid. Mainly boron acts as a Lewis acid. Then aluminium forms easily an aluminium hexafluoride also. Aluminium hexafluoride, and gallium is also form a gallium oxide. This aluminium and gallium has a amphoteric in nature. Amphoteric means which is forms more acidic as well as more basic oxides. That is, it has two characters, acid as well as base characters. That's called an amphoteric in nature. Then only the aluminium and gallium is called amphoteric in nature. Now indium acts as a very good semiconductors. Thallium is the most toxic elements, so we cannot use thallium in reactions. Then aluminium is more reactive compared to other elements, so it will be used in an anodizing process. Anodizing means it's nothing but electrolysis coating process. Aluminium easily interact with the adjacents as well as water molecules compared to other elements in this group, so aluminium is used in anodizing process. So in deficiency of aluminium in our body, it will cause us a Alzheimer's disease. Alzheimer's means memory loss. The deficiency of aluminium causes a memory loss disease, which is named as Alzheimer's. Then aluminium only forms a hexafluoride compared to all the five. Aluminium only forms a hexafluoride compared to all all the 5 because here it's only availability of more number of d orbitals, then only aluminum only forms aluminum hexafluorides. It is easily accept the electrons. The vacant d orbital is easily accept the electrons, then only it forms aluminum hexafluoride. Then aluminum oxide is also named as carundum, which is used to make a swellery rough tendency. Impure aluminum oxide is also contains ferric oxide, silicon is nothing but SiOSi. This compound is also called silicanes. Impure aluminum oxide contains ferric oxide as well as silicanes. This mixture is also called emery, which is used to produce a paper. Next, borons. 3 types of borons we know, like nido, closo, arachnoborons. Nidoborons, formula for nidoborons is BnHn+4. Closoborons means BnHn+5. Arachnoborons means BnHn+6. It is a general formula for the types of boranes. Borane nitrile is also called, it is a nitrile. Borane nitrile is also called inorganic benzenes. Then this borane is also used as a reducing agent in the form of lithium borohydride and sodium borohydride. And especially borane form diboranes. This is an example for diborane. This diborane contains PHB bonds. This bond is called a banana bond because here 3 centers are there: boron, hydrogen, boron. These are all 3 centers, 3 elements are there, so we are calling it 3 centers. 3 centers are shares, but here 2 electrons only forms a 2 electrons sharing between 3 centers. So this bond is also called 3 center 2 electron bonds. Another name of this bond is banana bond. Diborane only contain a banana bond. Banana bond is nothing but 3 centered 2 electron bonds. This 2 electron only shared between 3 elements. Okay. It also contains another bond, 2 center 2 electron bonds. Here it is a 1 center, this is another center which is sharing a 2 electrons. So this bond is also called 2 centered 2 electrons bond. Diborane containing a special bonds like a banana bonds. Borax, molecular formula of borax is Na2B4O7, and this borax is used for making jewels as well as it has a high resistance. Boron, at the same time, boron acts as a neutron absorbers in a nuclear power plants. Then sodium peroxyborate, it means peroxyborate. The name of this compound is peroxyborate. This peroxyborate is used for cleaning the clothes and bleaching. For this purpose we are using a peroxyborate. Already I told that boron trifluoride acts as a Lewis acid. Lewis acid is nothing but it accepts a lone pair of electrons. That is, it accepts the compound which accepts a lone pair of electrons is called a Lewis acid. Now we are going to see about carbon family. Carbon family contains carbon, silicon, germanium, tin, lead. Here carbon only have an covalent bond, pure covalent bond. Carbon have a pure covalent bond. At the same time, silicon is a second element in Earth, second abundant element in an earth crust. Silicon is a second abundant element in an earth crust. Carbon is the 17th abundant element in our earth crust. Germanium acts as a semiconductor. Then tin is also used for coating purpose. That coating purpose is named as an electrolysis. We are passing electricity for coating, so that process is called an electrolysis. Lead is used in reduce sound in vehicles. Lead in the form of tetramethyl lead or tetraethyl lead. These 2 components is mainly used to reduce the sound in a vehicle. At the same time, lead is an unreactive substance also. Here carbon, silicon, germanium oxidation state should be in a +4. Tin and lead most stable oxidation state should be in a +2. Here carbon forms a carbon 2 minus as well as carbon 4 minus compounds because of high electronegativity. How electronegative nature of a carbon, it forms in a carbon 2 minus as well as a carbon 4 minus compounds. Then allotropes of carbon. So what does mean by allotropes? Different structures of the carbon is also called allotropes. Different structures of the compounds, carbons are also called allotropes. That is, allotropes of carbons, first one is in a diamond. Diamond has its shape is a tetrahedral shape. So it is in a tetrahedral shape. Here each carbons undergo sp3 hybridations. sp3 hybridization, how do you identify sp3 hybridations? Here it is in a carbon, all the carbon atoms connecting a center carbon with sigma bonds. If the compound having 4 sigma bonds, it has an sp3 hybridations. If the compound having a 3 sigma bonds, means it has an sp2 hybridization. If the compounds have a 2 sigma bonds, means it has an sp hybridization. We are easily identified in organic compounds. In organic compounds, hybridization of our organic compounds. Now I am coming to diamond. Diamond have an tetrahedral shapes and it undergo sp3 hybridations. That is, the carbon-carbon bond is also called a covalent bond. In between the two carbons, it forms a covalent bond. At the same time, the covalent bond, all the covalent bonds are coming to closer with each other, so it does not conduct electricity. That is completely packed. All the carbons are completely closer and complete packed structure, so it does not conduct electricity here. So diamond does not conduct electricity. All the carbons of diamonds have an sp3 hybridations. Diamond having a shape like tetrahedral shape. At the same time, in between the carbons in a diamond has a covalent bond. Another allotropes of carbon like graphite. Graphite has a planar structure or hexagonal structure. Hexagonal means it is a hexagonal structure. Hexagonal structure. Carbon for this graphite has sp2 hybridations. In this case, electrons are easily transferred from one of the graphite row to another graphite row, so it will contain electricity easily. At the same time, between the two elements, between the two van der Waals force act between the van der Waals force, it is an imaginary force. Van der Waals force act between these two layers, so easily electrons are pulled from one layer to another layer. Easily electron jumps from one layer to another layer, so graphite contains electricity easily. Graphite has a planar structure as well as a hexagonal structure. At the same time, all the carbon in a graphite has sp2 hybridations. In graphite, it forms a layers between the van der Waals force. Van der Waals force act between these two layers are easily transferred from one of the graphite row to another graphite row, so it will contain electricity easily. At the same time, between the two elements, between the two van der Waals force act between the van der Waals force, it is an imaginary force. Van der Waals force act between these two layers, so easily electrons are pulled from one layer to another layer. Easily electron jumps from one layer to another layer, so graphite contains electricity easily. Graphite has a planar structure as well as a hexagonal structure. At the same time, all the carbon in a graphite has sp2 hybridations. In graphite, it forms a layers between the van der Waals force. Van der Waals force act between these two layers, so electrons are easily jumps from one layer to another layer, so it will produce an electricity easily. Another one, allotropes of carbon like Buckminster fluorine. It's also called bulky ball. It's also called buckyball or bulky ball. Okay. Another allotropes of carbon like Buckminster fluorines. It's also called buckyball or bulky ball. Here the carbon has an 60 carbons. 60 carbons are involved in bulky ball shapes. Each Buckminster fluorines contains 12 number of pentagonal shapes and 20 numbers of hexagonal shapes. 12 number of pentagonal shapes and 20 number of hexagonal shapes. At the same time, all carbon in this Buckminster fluorine has sp2 hybridizations. Here the another allotropes of carbons, that is the three allotropes are there. First one is in a graphite, another one is in a diamond, another one is in a Buckminster fluorines. Oxides of carbon, that is most stable oxides is carbon monoxide and carbon dioxide. Carbon dioxide is also called greenhouse gases. Then less stable oxide is carbon suboxide, carbon suboxide, that is C3O2 means it is in a carbon suboxide, it is a less stable oxide in carbon. Then least stable